Hello, welcome to Lodi Academy. Bismillahirrahmanirrahim. In this video, we will discuss about SGA tuning in Oracle. So, we will continue with the automatic shared memory. Using automatic shared memory management. Automatic shared memory management simplifies the configuration of the SGA by automatically distributing the memory in the SGA for the following memory pools: database buffer cache, which is default pool; shared pool; large pool; Java pool; streams pool. Automatic shared memory management is controlled by the SGA target parameter. Changes in the value of the SGA target parameter automatically resize these memory pools. If these memory pools are set to non-zero values, then automatic shared memory management uses these values as minimum levels. Oracle recommends that you set the minimum values based on the minimum amount of memory an application component requires to function properly. Memory caches are manually sized components and are not controlled by the automatic shared memory management, which are redo log buffer. The redo log buffer is sized using the log underscore buffer initialization parameter. Other buffer caches such as keep, recycle, and other non-default block size. The keep pool is sized using the db underscore keep underscore cache underscore size initialization parameter, as we will discuss later. The keep pool, as I mentioned, it is initialized by the db keep cache size. The recycle pool is sized using the db underscore recycle underscore cache underscore size initialization parameter. Fixed SGA and other internal allocations are sized using the db underscore nk underscore cache underscore size initialization parameter. The memory allocated to these memory caches is deducted from the value of the SGA underscore target parameter when automatic shared memory management computes the values of the automatically tuned memory pools. As you can see here, the key points: memory allocation. Memory allocated to these caches is deducted from the SGA target value. Computes value of automatically tuned memory pools, and used SGA target parameter is used to manage shared memory. Now we will see how to configure the redo log buffer. Several processes making changes to data blocks in the buffer cache generate redo data into the log buffer. The log writer process, LGWR, begins writing to copy entries from the redo log buffer to the online redo log if any of the following conditions are true. The redo log buffer becomes at least 1/3 full. LGWR is posted by the server process performing a commit or rollback. A database writer process, which is DBWR, posts LGWR to do so. When LGWR writes redo entries from the redo log buffer to a redo log file or disk, user processes can copy new entries over the entries in memory that are written to disk, which you can see in this image. LGWR attempts to write fast enough to ensure that space is available in the redo log buffer for new entries, even if it is frequently accessed. Having a larger redo log buffer makes it more likely that there is space for new entries and also enables LGWR to efficiently process redo records. On a system with large updates, if the redo log buffer is too small, LGWR will continuously flush redo to disk so that it remains two-thirds empty. On systems with fast processors and relatively slow disks, the processors might be filling the rest of the redo buffer in the time it takes the redo log writer to move a portion of the redo log buffer to disk. In this situation, a large redo log buffer can temporarily mask the effects of slower disks. Alternatively, consider either improving the checkpointing or archiving process. The performance of LGWR by moving all online logs to fast raw devices. To improve the performance of the redo log buffer, ensure that you are batching commit operations for batch jobs so that LGWR is able to write redo log entries efficiently. Using no logging operations when loading large quantities of data. Sizing the redo log buffer. The default size of the redo log buffer is calculated as follows. This max, you can see the formula, 0.5 M, 128K multiplied by number of CPUs. Set the value of log buffer initialization parameter to the required size in bytes. Applications that insert, modify or delete large volumes of data may require changing the default size of the redo log buffer. Oracle recommends setting the redo log buffer size to minimum of 8 MB. Set it to a minimum of 64 MB for databases using flashback functionality and having 4 GB or higher SGAs. Set it to a minimum of 256 MB if you are using Oracle Data Guard with asynchronous redo transport and have a high redo generation rate. To determine if the size of the redo log buffer is too small, monitor the redo log buffer statistics. You can also check if the log buffer space wait event is significant factor in the wait time for the database instance. If it is not, then the log buffer size is most likely adequately sized. To size the redo log buffer, set the size of the redo log buffer by setting the value of the log_buffer initialization parameter to the required size. The value of this parameter is expressed in bytes. Note, the size of the redo log buffer cannot be modified after instance startup, which means you have to shut down the database and start up, mount, then change the parameter or no need to shut down first change the value in SP file only and then restart the database, or shut down the database, change in the init file. For that you have to convert the SP file to init file if you are running, your database is using SP file. 2-3 ways. Other way is you can start database as a mount and change the value and then open database. So these are the ways. Now we will see how to configure keep pool. The purpose of the keep buffer pool is to retain objects in memory, thus avoiding I/O operations. Each object kept in memory results in a trade-off. It is more beneficial to keep frequently accessed blocks in the cache. Avoid retaining frequently used blocks in the cache, as this results in less space for other more active blocks. If there are certain segments in your application that are referenced frequently, then consider storing the blocks from those segments in the keep buffer pool. Typical segments that are kept in the keep pool are small, frequently used reference tables. To determine which tables are candidates, check the number of blocks from candidate tables by querying the $BH view. To configure the keep pool, compute an approximate size of the keep buffer pool. The size of the keep buffer pool depends on the objects to be kept in the buffer cache. To estimate its size, add the blocks used by all objects assigned to this pool. If you gather statistics on the segments, query dba_tables.blocks and dba_tables.emptyblocks to determine the number of blocks used. Taking two snapshots of system performance at different times, query data from the keep pool for each snapshot using the v$db_cache_advice view. Subtract the more recent value for physical reads, block gets and consistent gets from the older values, and use the result to calculate the hit ratio. A buffer pool hit ratio of 100% may not be optimal. Oftentimes you can decrease the size of the keep buffer pool and still maintain a sufficiently high hit ratio. Allocate blocks removed from the keep buffer pool to other buffer pools. Allocate memory to the keep buffer pool by setting the value of the db_keep_cache_size parameter to the required size. The memory for the keep pool is not a subset of the default pool. Note: if an object grows in size, then it might no longer fit in the keep buffer pool. You will begin to lose blocks out of the cache. Here we also will discuss configure recycle bin. You can configure a recycle buffer pool for blocks belonging to those segments that you do not want to keep in memory. The purpose of the recycle pool is to retain segments that are scanned rarely or are not referenced frequently. If an application randomly accesses the blocks of a very large object, then it is unlikely for a block stored in the buffer pool to be reused before it is aged out. This is true regardless of the size of the buffer pool, given the constraint of the amount of available physical memory. Consequently, the object's blocks do not need to be cached. The cached buffer can be allocated to other objects. Do not discard blocks from memory too quickly. If the buffer pool is too small, then blocks can age out of the cache before the transaction or SQL statement completes its execution. For example, an application might select a value from a table, use the value to process some data, and then update the record. If the block is removed from the cache after the select statement, then it must be read from disk again to perform the update. The block should be retained for the duration of the user transaction. To configure the recycle pool, allocate memory to the recycle buffer pool by setting the value of the db_recycle_cache_size parameter to the required size. The memory for the recycle pool is not a subset of the default pool. You can change the value of the SGA target parameter in the command line interface by querying the v$SGA_target_advice view and using the alter system command. To enable automatic shared memory management, set the initialization parameters like statistics underscore level to typical or all, SGA underscore target to a non-zero value. The SGA underscore target parameter can be set to a value that is less than or equal to the value of the SGA underscore max underscore size. Initialization parameter. Set the value of the SGA underscore target parameter to the amount of memory that you intend to dedicate to the SGA. To disable automatic shared memory management, set the value of the SGA underscore target parameter dynamically to 0 at instance startup. This disables automatic shared memory management and the current auto-tuned sizes will be used for each memory pool. If necessary, you can manually resize each memory pool. If you want to know about that, we will cover it in the separate video. Here I will give you one tip. Databases from 19C to above, they are very restricted to the memory. If you like, which is my personal experience, it happens to me, you cannot assign more than 80% of your physical RAM to SGA. If you assign that, it will not give any error, but database will not start. Means when you will set the parameter value of in the SP file and you restart the database, it will not start. It will give you error that insufficient memory. Then you have to go to your init parameter file and change the value, and then you can restart. So now it's a best practice that don't assign more than 75% to your SGA of your physical RAM, okay, for the safe side, because if you are assigning little more like 79% or 80%, it will not allow to restart the database. So here we will finish this. Hope you understand the SGA, how to set the SGA and what are the benefits. We will meet again in the next video. Till then, thank you very much. Bye bye.